This is Module 2, Lesson 12. Is there a relationship with the angles that are created when two lines are cut by a transversal? For this lesson, you will need your transparency and a protractor. I want you to open up your binder to Lesson 12 and follow the instructions for the exploratory challenge number 1. Notice the diagram is two lines, not parallel, cut by a transversal we call line M. Please pause the video while you work on this question now. Okay, welcome back. When you're done, your measurements may not be exactly what I have, but they should be within about 3 degrees. If they're very far off, it means something went wrong when you were measuring the angles and using the protractor. If they are off by more than 5 degrees or so, you should definitely come see me so we can just straighten out the protractor. Maybe you're having some trouble using it. So notice in this problem, the angles should have been about 117 for angle 1, 63 for angle 2, 63 for angle 4, 117 for angle 3. Angle 5 and 7 are 104, and 6 and 8 are 76 degrees. Within a couple of degrees, if you got that, that's fine. So which, if any, are equal? Well, it looks like we found that 1 and 3 are equal, and angles 2 and 4 are equal, angles 5 and 7, and angles 6 and 8 are equal. So now the next question is, well, why are they equal? Well, you should know from last year's work why they're equal. And you think of what the relationship is between angles 1 and 3, and 2 and 4, the relationship between 5 and 7, and the relationship between 6 and 8. Think for a minute. You should remember that they're called vertical angles. And they're equal because they're vertical angles. If you used your transparency, maybe you want to try that now, and rotate 180 degrees around the vertex of each angle, the angle will map to its opposite angle. So try it, and I'll try it here. So I'm going to rotate this. Now it's not going to come out as, I'm going to have to do it a little differently because I'm rotating on the smartboard. But let me I'm rotating the top circle. If you notice, look how nicely angle 4 lays on top of angle 2, and angle 1 lays on top of 3, and 3 lays on 1 on the top circle. And then if we go to the bottom circle, look how nicely 5 and 7 lay on top of each other, and 6 and 8 lay on top of each other. They're very nicely. So if you rotate them 180 degrees, they'll map right on top of each other. Hopefully you discovered that when you rotated your transparency. The more you do it yourself, the more you'll convince yourself, and you'll remember how that the angles that when they're vertical map onto each other. So vertical angles are equal in measure, since after we rotated 180 degrees, the angle mapped to its opposite angle. And since rotations are degree preserving, we know that from the last few lessons in this module, it means that angles are equal in measure. Now let's get some definitions. Corresponding angles. Corresponding angles are angles that are on the same side of the transversal in corresponding positions. So copy that definition. Pause if you need to pause the video, pause it while you copy this down. You need to have these definitions in your notes. This will be on the test. Okay, and copy down these. No, don't copy that down. Let's go look at the picture and see which angles are on the same side of the transversal in corresponding positions. So if we go back to this picture, if you notice, angle 1 and 5 are on the same side of the transversal, they're on the left side, and they're in corresponding positions. They're both in the top corner, the top left corner of the four angles. 1 and 5 are in the top left corner, and they correspond. What other angles are corresponding angles? Think about that, and we're going to list which other pairs of angles are corresponding angles. Well, you should notice that 4 and 8 are corresponding because they're on the left side of the transversal, and they're in the bottom left corner of the circle of four angles. What else are corresponding angles? What other angles are on the same side of the transversal in the same position? Well, you should see that 2 and 6 are corresponding. They're in the top right, and 3 and 7 are corresponding. They are in the bottom left. Okay? The next set of definitions are alternate interior angles. They are angles that are on opposite sides of the transversal and between the two parallel lines or on the inside of the two parallel lines. So let's go back and look at the picture from example 1 and examine and see which pairs of angles are alternate interior angles. Which angles are on the opposite side of the transversal but on the inside. Okay, well, if we look at the inside of the two lines, 3, 4, 5, and 6 are all on the inside. 1, 2, 8, and 7 are all outside those two parallel lines. So which one of those four, which two are on opposite sides of the transversal? Well, 4 and 6 are on opposite sides, and 3 and 5 are on opposite sides of the transversal. So 4 and 6 and 3 and 5 are alternate interior angles. The last definition is alternate exterior angles. They're angles that are on opposite sides of the transversal, but they're outside the two parallel lines. They're either above line 1 or below line 2. So copy this down. If you need to pause the video, pause it, and we're going to go back and look at the picture of the 8 angles. Here you can see that 1 and 2 are above line 1, and 7 and 8 are below line 2. So they're outside these two lines. Well, which two of the four, which two are on opposite sides? Well, 1 and 7 are on opposite sides, and 2 and 8 are on opposite sides. Now you're going to work on exploratory challenge number 2. This time I want you to look at the picture in your binder, and what should you immediately notice about the pictures? How they're different, how one is different. Challenge 1 is different from challenge 2. That's right, you should see that in challenge 1, the two lines, line 1 and 2, were not parallel, but in challenge 2, lines 1 and line 2 are parallel. And so you're going to use the protractor and measure your angles and list the angles that are equal in measure. So again, they should be within a few degrees of what I have measured. So pause the video and work on that now, and then answer the questions for A, B, and C for that question. Okay, let's look at the angle measures that I have. I had to write over them in on the smartboard because the image didn't copy very well. So it's the same picture that you have. There's angles 1, 2, 3, and 4, 5, 6, 7, and 8. And the degree measures are 39 degrees, 1 and 3, and 5 and 7, and 141 degrees for angles 2 and 4, and 6 and 8. So let's discuss some things that you should have observed while you were working on this. So we're going to discuss what you observed when you measured and compared the angles in this challenge. And what we're going to do is make some informal arguments to prove some of the things you noticed. So each time you answer why or how do you know or explain, you are making an informal argument. So keep that in mind. If you're asked to give an informal argument, it's a very simple thing they're asking you to do. They're asking you to explain the why of something or how do you know? Or they're just basically asking you to explain the picture. But they're stating it in a more mathematical way, and they're saying, make an informal argument for blah, blah, blah. So were the vertical angles in challenge 2 equal like they were in challenge 1? Why? Well, you should have noticed that the vertical angles were equal. 1 and 3 are equal, and 5 and 7 are equal, as they were in challenge 1, and for the same reason. If you rotated around the vertex, 1 would lay on 3 and 5 would lay on 7. Same reason as in the first one. What other angles were equal in the second diagram here when the lines L1 and L2 were parallel? Well, it's obvious that 1 and 3 are equal, 5 and 7 are equal, and 2 and 4 are equal, and 6 and 8 are equal. And they're vertical angles. Now let's look at just angles 1 and 5. What kind of angles are these? Remember our definitions. Go back to the definitions. What kind of angles are 1 and 5? Right, they're corresponding angles because they're on the same side of the transversal and in corresponding positions. We've already said that these two angles are equal in measure. Why do you think that is? Why can you explain why this is so? Well, notice if you translate along a vector that maps 1 to 5. So let's slide this transparency down. Let's pretend there's a vector. And we're going to slide down the vector, and notice how angle 1 can lay right on top of angle 5. So we're just translating, and they fit together rather nicely. Translations preserve degrees of angles, so the two angles are equal in measure. And notice the other angles too. If we translate these 4 angles, 1, 2, 3, and 4, along this vector, what do we notice about the other angles? Well, 2 and 6 translate and lay on top of each other, 3 and 7 lay on top of each other, and 4 and 8 do. So the translation moves all 4 of those angles from up here to down here, and we could also move the ones down here up to the top. So you could translate in either direction along the same vector. So all of the angles formed by the intersection of line L and M, line L1 and M, are translated along a vector we could imagine here, along M. And that's why the corresponding angles are equal in measure. So what do you notice about 3 and 7? Well, these two angles are also equal in measure for the same reason as 1 and 5. They're corresponding. And what other pairs of corresponding angles are in the diagram? That's right, 4 and 8 are corresponding, and 2 and 6 are corresponding. Now, in the challenge number 1, the pairs of corresponding angles we named were not equal in measure. Given the information that we have in each diagram, can you think of why this is so? Why were the corresponding angles in challenge number 1, why were they not equal in measure, but in challenge 2 they are? Let's go back to the first one. 1 and 5 are not corresponding. I'm sorry, they are corresponding, but they're not equal in measure. Notice if I lay the transparency so that line M coincides on the transparency, this line here, line L1, does not correspond to line L2. It's not lining up. So those corresponding angles are not equal. So why do you think that is? Well, in the first diagram, lines L1 and L2 were not parallel. So a translation of one of those angles would not map onto the other angle. And what about angles 4 and 6? They're corresponding angles. Nope, they're not on the same side of the transversal in corresponding locations. What kind of angles are angles 4 and 6? You should remember from our definitions that they're alternate interior angles because they're on opposite sides of the transversal and they're inside lines L1 and L2. So why do you think angles 4 and 6 are equal in measure? Well, you could use a rotation to map one of the angles onto the other, and rotations are degree preserving. So I have this orange dot here, which is on the picture here. And if I rotate this top transparency about that dot, now I'm going to do the best I can because I was not able to put a dot on this overlay transparency, but I'm going to rotate it. And when I rotate it, I have to line things up exactly. So let's rotate about that point. And you see that angle 4 lines up with angle 6. You should try this with your transparency. So you should use your transparency over the picture and find a point, the midpoint between the vertex here and the vertex here. Find the midpoint and rotate your transparency about this midpoint. I'm going to wait while you do that. Pause the video if you need some time to do that. So you should see that the angles 4 and 6 overlay each other and they're congruent. So the angles formed at the intersection of L1 and M under a rotation will map to the angles at the intersection of L2 and line M, but on the other side of the transversal. Name another pair of alternate interior angles. Besides 4 and 6, you should see that 3 and 5 are also alternate interior angles. Now, in the first challenge, challenge 1, the pairs of alternate interior angles we named were not equal in measure. Given the information provided about each diagram, can you think of why this is so? Well, it's the same reason as we just stated a few questions ago. In the first diagram, the lines L1 and L2 were not parallel, and a rotation about a point would not map one angle onto the other. So now are angles 1 and 7 corresponding angles? If not, why not? Well, 1 and 7 are not corresponding because they're not on the same side of the transversal, so they can't be corresponding angles. Are angles 1 and 7 alternate interior angles? No, because they're not on the inside of lines L1 and L2. Well, what kind of angles are angles 1 and 7? You should know they're alternate exterior angles because they're on opposite sides of the transversal and above L1 and below L2. What's the other pair of alternate exterior angles between angles 1 and 7? You should see that that's angles 2 and 8. And these pair of alternate exterior angles were not equal in challenge 1. And why do you think that's so? Well, it's for the same reason as we said before. In the first challenge, lines L1 and L2 were not parallel, so a rotation of one of those angles would not map onto the other angle. So now, if you know that the pairs of corresponding angles, alternate interior angles, and alternate exterior angles are congruent, what do you think is true about the lines? Well, you should have come to the conclusion now that the lines are parallel when the pairs of corresponding angles, alternate interior angles, and alternate exterior angles are congruent. So now we have a theorem that you could copy. Before we do that, these are some of the answers you could have gotten for A, B, and C. What did you notice about the measures of angle 1? Why do you think this is so? Angle 1 and 5 are equal in measure. We can translate angle 1 along a vector on line M so that the vertex of angle 1 maps onto the vertex of angle 5. And translations are degree preserving, so the two angles will coincide. Coincide, that's a vocabulary word. So make sure that you're copying these answers in your binder. You will need this when you study. What did you notice about the measures of angles 3 and 7? Why do you think this is so? Use your transparency if needed. Are there any other pairs of angles with this same relationship? If so, list them. Well, 3 and 7 are equal in measure. We can translate angle 3 along a vector on line M so that the vertex of angle 3 maps onto the vertex of angle 7. And translations are degree preserving, so the two angles will coincide. Other pairs of angles with the same relationship are angles 4 and 8 and 2 and 6. And the last part, what did you notice about the measures of angle 4 and 6, and why do you think this is so? Is there any other pair of angles with this relationship? the measures of angles 4 and 6 are equal. A rotation of 180 degrees around a center, that orange dot that I had showed you, would map angles 4 to 6. So rotations are degree preserving, so we know that angles 4 and 6 are equal. Angles 3 and 5 have the same relationship. You have this information in your binder. At any point, you can rewind or go back on this video or pause it. You need to slow down and copy the notes so you're really understanding them. And anything you don't understand, you need to come to class prepared to ask questions about. The definitions, you need to understand the differences between those 3 different types of angles we've discussed so far. So then what have we come up with? Well, we've come up with a theorem. We've discovered the theorem that when parallel lines are cut by a transversal, then the pairs of corresponding angles are congruent. The pairs of alternate interior angles are congruent, and the pairs of alternate exterior angles are also congruent. The converse of this is also true, meaning if you know that corresponding angles are congruent, then you can be sure that the lines cut by a transversal are parallel. Can you think of how you could rephrase the converse of the theorem using other types of angles we learned about today? Try. Pause the video and try. Make sure you're copying all of this theorem down and the converse. So pause the video now to copy this down, and then I want you to think of how you could rephrase the converse using other pairs of angles you learned about today. Well, when alternate interior angles are congruent, then the lines cut by a transversal are parallel. When alternate exterior angles are congruent, the lines cut by a transversal are parallel. Copy this now. Pause the video to copy this. So now I want you to read the lesson summary on page 65, which basically states the theorems and the converse. It discusses what corresponding angles are. It discusses what alternate interior angles are and what alternate exterior angles are. And then it discusses when parallel lines are cut by a transversal, the corresponding angles, alternate interior angles, and alternate exterior angles are equal. If the lines are not parallel, then the angles are not congruent. Be prepared with questions on lesson 12 when we meet again on this. This concludes lesson 12.